All right. So, Euler has come through and he has said, I want to find a way to start at some point on my graph and be able to trace every line once and only once without lifting my pencil. Okay. If I can do that and make my way back to the first point where I started, we're going to call that an Euler circuit. If I can trace every line and start at one point and end at a different point, we're going to call that an Euler path. And if I can't do it at all, it's called neither. Okay? So, basically what you're going to do is they want you to take your pencil. Can you put it on this dot? Can you trace every line in this picture once and only once without lifting your pencil? Okay? Well, sure I can. But I started here and I ended here when I did that. Okay? So, in that case, this is called open, or in other words, an Euler path. Because remember, a path means I start at one point and I end at a different point. What makes it Euler, though, is you have traced every line. When we just talk about a path, you don't have to touch every line. If it's an Euler path, you have to touch every line once and only once. Okay? Try the second one in the middle. See what you can do with that one. Can you trace every line? No. Once and only once. No. Can't do it?
No. No way you can get to the square.
Yeah. Why? I can stop here.
Yeah, you can. You won't start and end at the same place, though. She freaking did it. I didn't know.
You gotta be good at puzzles.
Right.
That's all right. When we get to Flurry's algorithm, I'm going to give you the cheat. There's a cheat. Okay, so this is called closed, or in other words, an Euler circuit. Okay, that one is a closed one, or an Euler circuit. This last one's going to be neither. There is no way to finagle this craziness. Bless you. There is no way to finagle this craziness without retracing things. Okay. If I try it, I miss this whole chunk. Okay. I'll miss chunks in the middle. It's just not going to work. Okay, so a path is open and a circuit is closed. Okay. The only way I remember that is circuit has to do with NASCAR. They're making a left turn. They're making another left turn. And guess what? They don't cross the finish line until they get back to the start. Okay, so it's closed. It's a big old oval. Okay, so definitions are already written there for you. An Euler path is a path that travels through every edge of the graph once and only once. Okay? You start. Oops. Or not, because my board hates me again.
Guess what?
What?
Yesterday at the end of practice, I had to do sprints.
I know, I heard. Guess you should all show up to practice sometime.
I have my siblings. I even come late to games because of them.
We start and end at different points. Okay, an Euler circuit. A circuit that travels through every edge of a graph once and only once. But this time, we start and end at the same point. That's a big difference.
We didn't answer number 2.
Okay, we're gonna do a little bit of investigation because it's fun. And you're gonna actually come up with the way to solve these the easier way.
We didn't answer number 2.
We didn't answer number 2. Oh, what additional characteristics or requirement is universal tracing? Every edge once. Sorry, I missed that one. My bad. Every edge once.
Power school still down.
No, Power School is back up. Your grades are 100% up to date as of today.
No, I was about to say that 50 that I got your seat.
I don't like you, bro.
You really don't.
Okay, so take a look at this. Graph number 1. Can I do a circuit or a path here?
Circuit.
This one's a circuit. It's a big old square. I can start at A, make my way straight back to A. This board is already off. I'm still over it. Circuit. Okay. What's the degree at A?
2.
2. What's the degree at B?
2.
C?
2.
And D is 2. Oh my God. I'm sorry. I've got to fix this board again.
I think that's fun doing that. I
You
mean,
think
not
it's
for you.
fun?
But like, if I see it.
Not when I have to do it 17 times in a class.
But like, I have the urge to. You can't even read the top. I can't. Wait, can I? I think I'm like that tall.
Are you that tall?
I'm 5'1.5". So get a half.
Okay. How many total edges are in graph 1?
4.
4.
Oh, I thought you were talking
Okay. Oh my goodness. C, 2, 2, 2, 2, 4. Take a look at graph 2. Can we do an Euler circuit or an Euler path? This one's going to be a path. Okay? I can start at A, but when I finish, I end at C. Okay? So here's my start, here's my end, which is what makes that a path instead of a circuit. Okay? What's the degree at A?
3.
What's the degree at B?
2.
C?
3.
And D?
2.
How many total edges?
5.
5. Try graph 3. Circuit or a path?
Circuit.
Circuit. Okay, I can start at A and I can make my way straight back to A. So this is a circuit. What's my degree at A?
4.
4. Okay, what's my degree at B?
4.
Where are we at C?
2.
And D?
2.
And how many total lines?
6.
6. What about graph 4? This one's going to be a path. Okay? Once I leave A, there's no way to get back to A without retracing. So I started at A and I ended at B. Okay? A has a degree of
1.
B,
3.
C,
2.
D.
2.
Total edges.
4.
You're fine.
You got 3.
Yes, B has 3. It's got the line that goes up to A, the line that comes down to
yeah.
C, and the line that comes down to D. Okay. Please, if you're questioning anything, I need you to stop me. I will gladly go over it. Don't lose yourself because you think this chapter is easy. Okay. The last one then. What do we got?
9.
This one is a path. Start at F.
Oh, I always got the thing that you always got to start.
You don't have to always start at A. Okay. So yes, this one is a path. How many does A have?
2.
B.
2.
C.
3.
3. C goes up to B, out to F, and down to D.
I was about to say, you guys are. I thought I got up on you. Right. Like, I thought I got up on you. What?
Okay. D is at
2.
E,
2.
F.
3.
Beautiful. And how many total?
7.
7. Okay. So you can go ahead and flip the page, but as you're flipping the page, take a look at this. Okay. Your first one over here and this one right here were both circuits. What do you notice about the degree of both of these? They're all even numbers. If you have a circuit, every one of your degrees is an even number. So, in other words, to tell me if it's a circuit, you just have to count the degrees. You don't even have to find it. You just have to count the degrees. Take a look at my paths. Path here, here, and here. Both odd and even. How many odd are in each one?
2.
Exactly 2. If you have a path, you have exactly 2 odds. Everything else is even. If you have 1 odd, it's nothing. If you have 3 odds, it's nothing. If you have 4 odds, it's nothing. It has to be exactly 2. So that brings me. Oh, actually, hold on. Let's go back. Take a look at your path again.
I was going to say because.
Okay. So take a look here. We started at F and ended at C. What type of vertices are those? C is 3, F is 3, so these are what type of vertices? Odd. Take a look at this one. We started at A and ended at B. A is
1.
B is
3.
which means they're both odd. Okay, same thing over here. We started at A and ended at C. Odd, odd. So if you ever have to draw the path, you must start at an odd number and end at the other odd number. Okay, so Euler circuit. What type of vertex can you start and end at? Any of them. You can start and end at anything you want, but it must be the same. Okay. Unless they're specific and says you need to start at C, you can start at any one of the vertices you want. You just have to make your way back there. Okay. What do all vertices have in common? They're all even. On the other hand, what type of vertex can you start and end at on an Euler path? Okay, so we start at an odd and we end at the other odd. Okay, so when you're trying to draw yourself a path, you need to find your 2 odd vertices. You will start at one of them and you will end at the other. What is true about the vertices in all Euler path cases? Exactly 2 odd. Anything else and it's nothing.
I don't get that. But okay.
What do you mean you don't get that?
I'm just kind of.
So let me see if I can draw one here. 1, 2, 3, 4. 1, 2, 3, 1, 2. Okay, so what's my degree at each one of these?
3.
3. So this is 3, 3, 3, 3. Okay, take a look what happens when I try to trace this. I'm stuck. I cannot create a path because I have more than 2 odd vertices. There's no way to do it. You can try it any which way you want. I'm still stuck. I can't do that diagonal. So anytime you have more than 2 odd, it's nothing. You can never create a path. You can never create a circuit. So that's what you're going to look for. Okay. Does that make a little bit more sense?
I don't want to say yes, but
We're going to do a lot more examples today. So hopefully that will help. Okay, so you just came up with these theorems all on your own. Okay, so the theorems that you just came up with state if a graph has any odd vertices, then it cannot have an Euler circuit. Remember, we said the Euler circuits have to have all even. So if there's any odds, it's automatically not a circuit. Or on the other hand, we can also state that if a graph is connected and every vertex is even, then we have at least one Euler circuit. Okay? It's just 2 different ways to write the theorem.
yeah.
This one.
Yes.
Cannot is one word.
Yes.
Okay.
We also came up with the Euler path theorem that says if a graph has more than 2 odd vertices, then it cannot have an Euler path. And again, I can say that in a different way. I can say if a connected graph has exactly 2 odd vertices, then it has a path starting at one odd vertex and ending at the other. We've got one more theorem that we're going to discover. Yay, us. Okay. One more theorem, and then we're going to practice all this. Everybody got this? All right. Take a look at graph 6. What's the degree at A? 2. B is 2. C is
3.
D is
3.
D is 3. Careful, D goes to C, E, and G. Okay. E is 2. F is
2.
G is
2.
what's my total amount of edges?
8.
Okay. Let's do 7. Ooh, actually, let me give you a minute to do 7 and 8 because 7's kind of a little bit crazy. There's some extra lines there. So take a minute and do that one, and then we'll put them up because you need a little bit of time to count some of those. They get a little ugly.
So I have a question. Graph 6
cannot be an. Wait, can this also work with the current, like the Euler current theory? So graph 6 cannot because it has an odd vertex.
You know that's late.
So a loop counts as 2 degrees, right?
When I asked first, we turned into
A loop counts as 2 degrees, right?
yeah.
Nah, but if they tripping me, crashing me, I probably fell out the car like, oh, yeah.
So graph 6 would be an Euler path.
Yeah, that's what I'm saying. It couldn't be a current.
It could not be a circuit.
I mean, yeah, circuit. I don't know why I said current.
Yes.
Graph 7 has only one even. So it is not.
Neither.
Wait, why would it be neither?
You said they're all odd and just one even?
Yeah.
Because you need exactly 2 odds to be a path.
7 has 2 even.
What?
7 has 2.
No, that's only. Oh yeah, that's.
7 has 2.
Yeah,
Two
Two evens,
I
yes.
didn't see- I-
But because it has 4
Oh, yeah,
odds and not exactly 2, it's nothing.
It's neither.
Yes.
What? That group.
What group?
From yesterday.
Oh.
That family. Yeah, that family. That was there. So like, it was closed. Oh. It was there for a long time. It was on like for relaxation.
Okay.
And what would graph 8 be?
Total edges?
All 3 of them total edges.
Instead of your
No, I'm
quiz.
saying would it be a?
I got
We're
you.
not doing that.
I'm trying to understand it, you dumb hoe.
Well, then it's after this.
That's what I was asking. Yes, no, I was
Really?
like, so Miss Smith. What would
Really?
it
She said
be? You got on me when I wasn't even talking to you like that.
you just said it out loud. You
No,
said
no,
it
Stop.
too.
no.
That was out of you.
Now she got to edit.
We're not even mad.
No, technically I gotta write it up now.
Why?
Try freaking YouTube. Because you can't watch your mouth.
I forgot.
Yeah. Every time. Killing me.
Wait, I got a question.
What?
You got a video of that?
Huh?
Where is that?
Do I have the video?
Yeah.
No, but I do because I'm not reteaching anything that I taught.
Well, dang, y'all.
I don't got time for it. And when I have seniors, I've got way too many of you that miss way too many days. And I don't got time to play catch up.
What about your third period? Do you know?
I mean, I they just use your guys' video. I do the same thing second and third. Oh, that's what Troy said. You're welcome.
We're not going to hear the question. Okay.
Right. Okay, graph 7. What's the degree of A? 5. What was B?
5,
C,
5,
D,
3,
E,
8,
and F.
4,
And how many total edges?
15.
15. Okay. Graph 8 then. A had
2,
3.
3. Okay, remember. 2 for the loop and then 1 for the line that goes down to C.
Well,
Okay.
They all 3.
Same thing with B. 2 for the loop, 1 for the one that goes to C. They all have 3. Wow, that's a really funky looking 3 there. And how many total lines or edges do I have? 6 total. Okay. So let's go back and talk about the theorems we just talked about. So looking at the degree on number 6, should I have a circuit, path, or neither? This should be a path. Okay. Look at graph 7, circuit, path, or neither? This should be neither. And what about 8?
Neither.
Neither as well. Okay. All even for a circuit, exactly 2 odd for a path. Anything else is neither. Okay. So they want to know, describe the relationship between the total number of edges and the degree of all of your vertices in your graph. So, in other words, if I total up all of these numbers for graph 6, what do I get? 16. If I add up all of these numbers in graph 7, what do I get? 30. And what if I add up all the ones in graph 8? What do you notice about the total degrees and how many edges you have?
Half of it.
It's half of it. Okay? You just came up with your last theorem. You just came up with your last theorem. So, your number of edges is your total degree divided by 2. So, if your graph has a whole bunch of crazy lines everywhere and it's hard to count your edges, just add up all your degrees and divide it in 2. And that will tell you how many edges you have. Okay? If for some reason you cannot divide by 2, you did something wrong. You should never end up with like 10 and a half. You can't have half a line. Or you can also say your total degree is 2 times the number of edges. So if they tell you your number of edges are 7, you should be able to tell me your total degree is 14 then. Okay. If we flip back to graphs 1 through 5, does this also work here? Yes. This is 8. This is 10. This is 12. This is 8. And this is 14. Okay, so this should always work. Okay. So, in words, what the heck did we just talk about? It says the sum of the degrees of all the vertices of a graph should equal twice the number of edges. Or we can always say a graph always has an even number of odd vertices. So in other words, I can't have a graph that has only one odd vertice. I cannot have a graph that has only 3 odd vertices. There has to be an even number of odd vertices. Okay, summary of all this. If I have no odd vertices, what do I automatically have? Circuit. If I have no odd, that means they're all even. So if I have no odds, I have a circuit. If I have 2 odds, we've got a path. If I have an even number of odd vertices, I have neither. If I have an odd number of odd vertices, it's not neither. This just can't happen. Okay. I can never have an odd number of odd vertices. It will never, ever, ever happen. Okay. They just don't exist.
Please pardon the interruption. Ms. Shove, could you please stop by the front office? Ms. Shove.
Yes.
Can you go back a slide?
Can I go back a slide?
Yeah, okay. Remember. I got it. You know you can do.
So if I back up to here where you told me neither, how many odd vertices did I have in graph 7? 4. That's an even number of odd vertices. How many did I have in graph 8? 4. Okay, so you will always have an even number of odd vertices. Okay, that's what that's telling you. All right, let's finish this chapter off, friends. We're about to finish this off. Okay. So, Euler's theorems are great because Euler's theorems do identify the existence of an Euler circuit or an Euler path. So it will tell you, yes, you have one, or no, you don't. What they do not tell you, though, is they do not find a specific path or circuit. So it will tell you, yes, I have one, but it's not going to find it for you. You're going to have to do that leg of work on your own. So the way that you do that, okay, this is the last bit. First thing you want to do is you want to number the degrees of each vertex, okay? So you're going to come to this graph and you're going to say, okay, this has a degree of 2. This has a degree of 1, 2, 3, 4. This has a degree of 2. Everybody good with those 3?
Yeah.
Okay. This one has a degree of 4, 4, and 4. 2, 4, and 2. So, according to Euler's theorems, what should I have here? This should be a circuit. Okay. So, because this is a circuit, I can pick any point I want to start at. Where do you want me to start? Dead center? Okay. So, if I start at the dead center, that means I have to trace every line and make my way back to that center point. Okay? So, I'm at the center. Where would you like me to go? Up. So that would be side 1. Now where do you want me to go? To the right? Okay? So that would be side 2. Now where? Down. Side 3. Now where?
Across or diagonal or whatever.
You tell me. It don't matter.
Isn't it diagonal?
You want to do diagonal?
Yeah.
Okay. So there's 4.
To the left.
To the left, because I have to. There's 5.
Down.
Down, I have to. There's 6.
Down.
Down again. Okay, there's 7.
Right.
To the right, there's 8.
Diagonal.
Diagonal, there's 9. I have to go across.
Down.
There's 10. Down is 11.
To the right.
To the right is 12.
Up.
13.
To the left.
14. I traced every line and I made it back to where I needed to go. So you just found an Euler circuit. So the first thing you're going to have to do is identify what is it. Then you're going to have to find it by tracing the lines. Okay? Let's do this second one. Okay? Degree of this dot, 3. Down below,
2.
2. Over here,
3.
3.
4.
4. Up here,
4.
4. Here,
4.
and here.
2.
So what should I technically have here? This should be a path.
Real quick.
Yes.
How many triangles are there?
How many triangles are there? Oh, God. You're going to make me do one of those?
6.
1, 2, 3,
6.
4, 5, 6.
Wait. Yeah, 6. 6. 6.
I'm only getting 6.
Yeah, only
Because you've got each individual one, and then you've got this big one here.
That was such a random.
I only got 6. Is that all you got? You're making my head hurt.
know what you got.
I got it.
She didn't even
Okay,
know she had
when you have a path, your path needs to start at one odd and end at the other. Doesn't matter which one you start and which one you end at. So which one would you like to start and which one would you like to end?
Left corner.
Left corner start. So that means I need to finish here. So I need to start up there. I need to trace every line before I get to that last one. Okay, I need to stop here. So if I'm here, which way would you like to go?
Left. I mean right. My bad.
I was going to say I can't go left. There's 1.
Right.
Right again.
Down.
There's 2. There's 3. Up, you said? Okay. 4,
Diagonal down.
5,
To the right.
to the right.
Yeah.
Okay, there's 6.
Diagonal down.
Diagonal down. There's 7.
Go up.
There's 8.
Okay.
And up.
There's 9.
Down.
There's 10.
To the right.
There's 11. I started at one odd, ended at the other. And you just found an Euler path. It's not too bad, right? Okay. So all this happy stuff just explains in words what the heck we just did. Okay. So first you're going to determine the existence. If we have no odd, you're going to tell me it's a circuit. If we have exactly 2 odd, you're going to tell me it's a path. If you have anything else, you're going to tell me it's neither. If it's neither, you can leave it alone and move on with your life. Okay. If it's a circuit, you can choose any vertex you want unless it tells you where to start. Okay. In an Euler path, you have to pick one odd vertex to start and the second one to finish. And you're going to trace the edges and number them as you trace them to create that path or circuit. Okay. So you have, what is that, 11? You have 11 problems for homework. The rest of this packet. Okay. So first thing, tell me, path, circuit, or neither. Okay. Create your path or circuit by numbering your edges like we just did. Okay. It tells you if it's a circuit, they want you to start and end at A. Okay. So they're telling you you have to start and end at A. Okay. If it's a path, pick one odd to start at and one odd to end at. Okay. I'm going to help you out. You have 1, 2, 3, 4, 5 circuits. 1, 2, 3, 4, 5 paths, and 1 neither.
A path has to have 2 odds.
Exactly 2 odds. Okay, so you have 5 circuits, 5 paths, 1 neither. Okay, tomorrow we will review chapter 5 because we are done. You just smacked chapter 5 in the face. Okay, we will test on Friday. Yes, ma'am. Yes, ma'am. Okay.